let's go here and just click to the objects, and then we're gonna have, let me see, a tile map. So let's give it a try in hexagonal flat tap. So let's see what happens. So this is what we have right now. So we have this tile map, and let me see, let me focus it. Okay, so oops, no. So this is the tile map that we have. The I think it was hexagonal. Let me double check. So tile map and then hexagonal flat tap. So, and right now we cannot see it yet. Okay, but let me see if I can make this one. No, we cannot see it yet. Let me see the main camera. Okay, so yeah, but still we have the tile map here. So the tile map component is a system that stores and handles tile assets for creating 2D levels. Use the 2D tile map editor package installed by default to use tile maps. For example, you can use tile maps to paint levels using tiles and brush tools and define rules for how tiles behave. So this is an example that they're giving us. The tile palette window used to edit tile maps. Now we have the 2D tile map extra. So to add some extra tile maps assets to your project, install the 2D tile maps extra package. This package contains reusable 2D and tile maps editor scripts that you can use for your own project. You can customize the behavior of the scripts to create new brushes that suit different scenarios. We have the isometric tile maps for games with isometric perspective. You can create isometric tile maps. So let's check out that one. Let's just get rid of that. So delete, and now it was 2D and then tile maps, and it was isometric. So let's give it a try. So we have that, and okay, so we cannot see it. Okay, but it's there. Let me see, it's in 2D. Okay, so away from the camera. Okay, that's fine. Okay, yeah, we're dealing with, let's keep it in 2D. So this is the isometric. Okay, so isometric tile maps for games with isometric perspective. You can create isometric tile maps sprite shape in a similar way to a vector drawing tool. Sprite shape provides a more flexible way to create larger sprites such as organic looking landscapes and paths. So you can check out this link as well, a path created with sprite shape. And now finally we have the working with sprite shape tutorial. Now character animation. So we have, there are 3 different ways you can animate 2D characters. So 2D animation frame by frame, used for artistic reasons. If you want your game to have a classic animation art style, frame by frame animation is relatively resource intensive both to make and to run. Cut out smooth skeletal animation when the characters don't require realistic articulation. And finally skeletal smooth skeletal animation where sprites bend according to the bone structure. Use this when the characters need more organic feel. Okay, so this is an example of the frame by frame animation. Is based on the traditional cell animation technique of drawing each moment of an animation as individual images which are played in a fast sequence, like flipping pages on a flip book. To do frame by frame animation, follow the frame by frame animation flow. But pretty much this is what we have, and it's pretty much, as you can see, we have the same image here and the same image. Well, this would be our hero and this would be our enemy, but pretty much as you can see they're changing. Okay, so frame by frame animation and the sprite editor. Now we will have the cutout. So in the cutout animation, multiple sprites make up the body of a character, and each piece moves to give the visual effect to the whole character moving. This animation style is similar to the skeletal animation, see below skeleton, except for the sprites don't bend. And in this case, as you can see, we have the whole player, but well, the parts that made the player are separated. So we have one arm here, another arm there, one leg over there, another leg over there. It's like I don't know, like a Transformers or some kind of stuff like that. where you have all those parts separated. Okay, so cutout animation. Now we have the skeletal. Okay, with a skeletal animation, you map a stripe, a stride, or a group of sprites into an animation skeleton. You can create and define animation bones for characters and objects that define how they should bend and move. This approach allows the bones to bend and perform the sprites for a more natural movement style. To use a skeletal animation, you need to use a 2D animation package installed by default. For a 2D animation workflow, including a guide to working with the bone editor, see the 2D animation documentation. So this is how it will look like. Okay, so we have the preview pose, the edit bone, create bone, split bone, some geometry, some weight. So we will deal with some physics here. A character with bones and the bone editor. Okay, now graphics. This section describes the graphics options when using Universal Render Pipeline. So the URP, Lightning. Because you're using URP with the 2D renderer, you can use the Light 2D component to apply optimized 2D lighting to a sprite. And for details, you can check out that. So this is the lights, 2D lights off, 2D lights on. Let me see if we go into the hierarchy. So 2D, we have sprite, physics, tile maps, sprite shapes. We have the pixel, sprite mask, and then the sprites. Let me see, in tile maps and sprite shapes. We have effects here as well. We have the lights, so directional lights, spotlight. Okay, so we have all the stuff. Okay, so here into this particular image that they're providing, these two images show the same scene, and the image on the left 2D lights are disabled and the image on the right 2D lights are enabled. When the 2D lights, you can use the same sprite to create different weather conditions or moods. So to set up lightning, prepare your sprites for lightning. So you can check out this, set up a normal and mask textures. 2D lights can interact with normal map and mask textures linked to sprites to create advanced lighting effects such as normal mapping. We also have shadows, okay, to define the shape and properties that light uses to determine the shadows a cast. Use the shadow caster 2D component, increase the light shadow intensity above 0. So and here by default we let me see if we have it here, but in 3D we have like a sun that is I don't think we have it here right now. Okay, but by default we have some, let me see if I can add some effects or some lights or directional light. Okay, so now we have some directional light. Let me just move it to the, okay, so now we have, this is to cast some shadow. Let me see, but this is in 2D, so let me directional light, and let's just focus this one. Let's click here, and so what is the camera, the main camera? Okay, so we have that, and oops, no, this one. So we have the directional camera, so right now it's pointing in the C direction. I don't want that. Okay, let me see. Oops, let's just leave it in 2D. Okay, and directional light. Okay, so we only need the, this is the Y and this is the X, so we don't want to deal with the, let me see, we don't want to deal with the blue one because blue would be the Z direction. So let me see if I can, let me see if I can just move this one. No, doesn't let me do it. Okay, let me just put it, well, let me just leave it like that. Okay, so what else? So we have enhanced look and feel, particle systems, and post-processing are optional tools that you can use to add polish to your game. So we have also particle systems, so let me see if we can add some particle system as well. So let's take that one out and go to the hierarchy effects, particle system. Okay, so we have some particle system. Let me see. Okay, so, and the way that we don't see it is because it's not focusing the, okay, so now we can see it, we can see something right now because it's just, where is the camera? So it needs to appear here. Okay, if I go right here, okay, so this is the camera, the camera is focusing, yeah, right here. So that is the reason that we can see something in our game itself. So let me focus it. And what is the particles? Okay, so this is the particles, so let me focus as well. And now in the main camera. Okay, so let me make this one a little bigger. Okay, so now let's put it in the center right here, so this will be in the center as well. Okay, so this is some of the light particles or the particle systems. You can use particle system to create dynamic objects like fire, smoke, and liquids as an alternative to using sprites. Sprites are more suited to physical objects, so you can check out the particle systems. Post-processing. You can use the post-processing effects and full screen effects to significantly improve the appearance of your game. For example, you can use these effects to simulate physical camera or film properties, or to create stylized visuals. URP has its own post-processing implementation, so you can check out that. And we are using this part here, the inspector, as you can see. So they are using the transform, the volume, white balance, blue, all this stuff. And we have physics too. So the physics 2 settings define limits on the accuracy of the physical simulation of your 2D game. See physics 2. So this is a video, learn how to do the stuff. The following 2D physics tools are useful for 2D. So we have the rigid body 2D, collider 2D, triggers, 2D joints, and 2D effectors. There we have the rigid body 2D. So this will be how we manipulate that. It will be something similar, a tab similar to the inspector. We also have the collider, so we have the circle collider 2D, box collider, polygon. Okay, so if we go into, let me see, we go to the 2D object, so we have sprite, we have capsule, circle, square, I don't know, let's okay, we put a circle, and yeah, you can see it. And let me see if we can just, okay, so the camera, okay, so the camera doesn't move, but we have it as well in 3D. Okay, so we have that so far. And we have triggers as well. When you set a collider 2D as a trigger, by enabling its trigger property, it no longer behaves as a physical object and then can intersect with other colliders without causing a collision. Instead, when a collider enters the space, Unity calls the onTrigger enter function on the trigger game object script. So we check that. We have the 2D joints, the 2D effectors, the audio, the user interface, profiling, optimizing, testing, build, profiling, optimizing, testing, and finally the publishing. So when you're finished your game, you're ready to publish it, and you if you want, you can click at this link to check it out. Build settings, and here then there's, well, whatever you're using, a Mac, a Linux, Windows, in my case Windows. And okay, so that is in the build settings. So if we go here and we go into file, if we go in build settings, yeah, if we go into file, we go into build settings. So as you can see, we have this. So I have Windows, I have Intel 64. Okay, so we have WebGL here, so we have all the stuff, and that will be when you are ready to publish your game. And yeah, that's pretty much it. So this would be all that we have for creating a 2D game.